What's up, guys? Welcome back to another video. Guys, in this video I'm going to be showing you how to work some problems with transformations of linear and absolute value functions. So first thing we want to look at is horizontal and vertical translations. And just remember, guys, horizontal translations just means that you're moving side to side, left and right, and vertical translations are just up and down movement. So just remember to keep that in mind. So let's go down here to example 1, and we're going to work this out. So we're going to take this base function and we're going to move it 3 units down. And then we're going to work this problem again, and instead of moving it 3 units down, we're going to move it 2 units to the left. Just so you can see the difference between up and down and left and right when it comes to transformations on a function. All right, so let's start with the first one. We're starting with this function, 2x plus 1, and we want to move it down 3. So remember, when you move a function down, you will just add or subtract onto the end of the equation or function. So we'll have 2x plus 1, and then minus 3. Down 3 would be minus 3. Now, we can combine like terms here. 1 minus 3 is negative 2, so we can rewrite this just as g of x. And guys, I'm calling this g just because they identified it as g. Whatever's on the left side of the equation, that doesn't matter a whole lot. That's just the name of the function. But don't worry too much about the left side. The right side is what's important. So g of x equals 2x. And then combining 1 minus 3, we'll get negative 2. So there we go. This is the transform function. Now, let's do this again, but move it to the left too. So we're going to work part B now. Now, to move something left or right, we have to put it in parentheses, and I'm going to show you what this looks like. So we're going to put this in parentheses right next to the x. So sometimes you may hear me say that we are going to do, this minus 2 or plus 2 inside the x, or right next to the x. So what we're going to do is right when we get to the x, we're going to write the 2, and then right when we get to the x, we're going to put some parentheses in. And then 2 units to the left is going to be plus 2. Okay, left is plus, and right is minus. Close our parentheses, and then finish the equation. So it was plus 1 on the end. All right, so the only thing we changed here was we put in parentheses right around the x and added in that plus 2. All right, so left and right, you're going to do it in parentheses right next to the x, and up and down, we'll just stick it onto the end. Stick it onto the end. But this right here is the correct transformed equation. Now, you could, if you wanted to, simplify this a little bit, like you could distribute the 2 and then combine like terms, but honestly, this form right here is completely fine for transformations. All right, let's move on to reflections. So reflections, we have 2 types of reflections. We have reflections in the x-axis, and we have reflections in the y-axis. And we have 2 sets of rules for what we do to transform a function based on those 2 types of reflections. So I'm going to show you the difference on this example between x-axis reflections and y-axis reflections. But here are, and I'm going to try to get my face out of the way so you can see, here are the 2 rules for reflections. If we're reflecting in the x-axis, then we want to change the sign of all terms. We're going to change the sign of all terms. And then if we're reflecting in the y-axis, the rule is we only change the sign of the x. X only. All right? Change the sign of the x only. That's all. All right, so those are the 2 rules. So we're going to apply those, and we're going to reflect this function first in the x-axis, and then we'll reflect the function in the y-axis so you can see the difference. All right, so here we go. G of x, we are going to reflect in the x-axis, so we're changing the sign of all terms. So this first term, you could think of this whole package right here in these absolute value bars. You could think of that as one whole package, so we can just change the sign of that whole package. So negative x plus 3. All right. Again, anytime you have absolute value bars or parentheses, you can just change the sign of the entire thing, not everything inside it individually. Okay. And then we change the sign of the second term as well. So this will become minus 1. Now, let's look at part B. So that's the reflection in the x-axis. Let's look at the reflection in the y-axis and how that would be different. So h of x equals, we are just changing the sign of the x only. So we're going to have absolute value of, only the x gets changed. So we're going to have a little negative x in here, plus 3, and then plus 1. Okay, and someone asked me today when the negative sign goes on the outside of the absolute values and when it's going on the inside. I would say usually when you're doing y-axis reflections, it'll go on the inside, and usually when you're doing x-axis, it'll go on the outside, if that helps. All right, but anyway, that's your difference there. So you can see the difference between the two types of reflections. X-axis, we changed all the terms. Y-axis, we just changed the x term. Everything else stayed the same. All right, moving on down to stretches and shrinks. We're just going to be looking at vertical stretches and shrinks in this video. And so with our example, we're just going to work part B here and show you what a vertical stretch looks like. Here's the rule though. You're going to multiply the factor by every term. Whenever you do a vertical stretch or shrink, either one, you just multiply the factor by every term. So h of x is just going to be equal to, we're going to multiply that by this factor. So 2 times x minus 3, again, that's one package. You can think of that as one term. So 2 times absolute value of x minus 3 minus, and then you multiply 2 by the negative 5 as well, so that'll be negative 10. All right, so we multiplied the 2 by this first term, this first package here, and then 2 times the second term. And this right here is the transformed function. All right, let's now look at, finally at the end of this video, we're going to look at combinations of transformations. So what happens when we have more than one? Like for example, in this example, we have a shrink by a factor of 0.25, and then we're going to have a translation of 3 units up. And then this is the original function. So the important thing to realize here, guys, is that you have to do these transformations in the order that they're given in the problem. So we have to do the shrink first, and then we'll do the translation of 3 units up. So let's do that shrink first. If it's a shrink by a factor of 0.25, remember that you just multiply the factor by every term. In this case, we only have one term, so we'll just multiply the factor 0.25 times the x. Okay, that's the vertical shrink. Now for the translation 3 units up, remember that when we're moving up and down, we'll just add or subtract onto the end of the equation. So our final, okay, we're good. Our final equation is going to be g of x equals 0.25x, and then we're just going to add on 3 plus 3. That's your 3 units up. All right, and there you go. This right here is the transformed function. So you can do these. It's just the same as the problems up above. You just have to do them one at a time. Okay, let's do one more example. Example 5. Here's our starting equation right here. And we're going to do a stretch by a factor of 3. Stretch by a factor of 3. And then we're going to do a reflection in the y-axis. So let's do the stretch first. So we'll do g of x equals 3 times this first term. So we'll have 3 times absolute value of x. And then we want to do the reflection. So for the reflection, we'll do g of x. And in the y-axis, remember, we're just going to be changing the sign of the x only. So this will become 3 absolute value of negative x. Maybe make these little absolute value bars a little longer so that it doesn't look like a 31. And there you go, 3 times the absolute value of negative x. And that is your final transformed function. Okay guys, I hope you enjoyed the video. I hope this all makes sense. If you have any questions, feel free to leave a comment below and I'll get back with you. Anyway guys, thanks, and I'll see you in the next video.